Our circles have similar forms, I guess. Their equations look similar to our parabolas in terms of that whole h and k thing is still there. Only when I'm looking at an equation of a circle, I can tell it's a circle when both x and y are squared versus just one or the other. They also have to have the same coefficient. If I have 2x squared and 3y squared, it's a different shape, and we don't have time to go there this semester. Okay, but 1x squared and 1y squared, or 9x squared and 9y squared, okay, that's going to be a circle with a plus sign in the middle. Now, even though that is the form that we like to have it, so we can pull the center, so we can pull the radius from it, more often than not, it's given to us as a hodgepodge of terms. Like this. So remember completing the square that I just showed in the parabola video, if you clicked through that one. A little different approach in terms of we're not going to be adding and subtracting 4 or 9 or 25. We have two sides of the equation to work with. But we do get to complete the square twice. So half of 2 is 1, and 1 squared is 1. What I add to one side, I have to add to both sides of my equation. With the y's, I'm going to add a 4. And I factor, and then I combine like terms on the right. The center of my circle is -1, +2. We always change the sign, The radius is the square root of 9, and since that's a nice whole number, like 3, I'm going to write 3. If it was the square root of 10, I would leave it square root of 10. If it's the square root of 12, then I'll call it 2 square root of 3, always simplest form for all of your radicals. Okay. Maybe I can sneak a graph in over here. Okay. Actually, I'm going to erase this. Students rely so much on that grid and counting and stepping and hopping and walking. Okay, if I'm starting at the point -1, 2, okay, the expectation is that you're able to plot and label at least 4 points on your circle. Forgot to graph a line while I was making the line video. So if you have trouble with lines, plot and label at least 3 points on the line. Okay, 3 or more points. Here, since the radius is 3, we need to move 3 units in any direction that we want to, but the easiest ones to move are left and right and up and down. I can move 3 at the angle, but to know what that ordered pair is, I have no idea where I'm standing. But if I'm moving left and right is our x values. So if I add 3 to -1, I'm over here at 2. If I take 3 away from -1, I'm at -4. Okay, and the y value didn't change if I was just moving left and right. If I'm only moving up or down, then the x coordinate stays the same. I haven't moved left, I haven't moved right. But 3 steps up from 2, 2 plus 3 is 5. 2 minus 3 is -1. And then you try to connect it, and it's horrible with my tablet that I've got. -1, 2. Okay, so the circle looks approximately like that. Now, domain and range, you should be able to give me for any shape or function or relation that we've talked about. There's not all real numbers when we're dealing with circles. There's a very definite left end of the graph. There's a very definite right side of the graph. Here are those values. Okay, here's my lowest point, and here's my highest point. And since I actually step on those two values, I have to use square brackets there. Remember, a circle is not a function because it does not pass the vertical line test. Okay, I have my slides. I know I'm crisscrossing videos, but a parabola that opens up or down is a function. Okay, if nothing else, the key is to use our eyes and interpret. They told me f of x equals So I know that it's got to be a function. A straight line is going to be a function unless it's a vertical line. Okay, that's a function. That's a function. This is a function. Okay, vertical lines are not functions. Oops, back to the circles. So in a nutshell, that is, I think, what you need to know about circles. If you think of something that we left off, then that's fair game as well. But that is the gist of it.